Welcome everyone. My name is Rosemary from Molecular Cloud, and today we're interviewing iGEM Darmstadt. So if you guys could please introduce yourselves and your team and tell us more about your project, that would be awesome.
Okay, should I start? I'm Jan. I am participating for the second time, one of the students leaders this year, and yeah, anybody else?
Yeah, I'm Philip. Yeah, we have two Philips. I'm Philip Becker. And yeah, I'm studying here in Darmstadt biotechnology in the fourth semester, and this is my first year of iGEM. And yeah, I'm in the biofilm group in our team, and I'm the group leader of the human practice team. Yeah, that's so much to me.
So I'm the other Philip. I have the exact profile. I'm in the fourth semester for biotechnology at TU Darmstadt, and it's my first year at iGEM 2, and I'm the group leader of the kill switch group. So it's a lab group of ours, and I'm also a member of HP.
My name is Marvin. I'm 22 years old, and I'm currently studying biotechnology at the Technical University in Darmstadt, but I'm in the second semester right now.
Okay, and about our project, so this year we are trying to develop a biofilm, a B-subtilis biofilm that is able to render micropollutants or chemical compounds in wastewater less toxic or degrade them completely.
Exactly. Yeah, we do that by using lacases, and yeah, they are very good in degrading micropollutants. Yeah, and we are we use them. We are going to immobilize them in our matrix, in our biofilm. So by doing that, we are using a matrix protein of Bacillus subtilis, which is our organism we work with, and yeah, we fuse it, and then we have the lacase in our matrix, and hopefully it works. That we can degrade a lot of pollutants.
Maybe we can also add to this that we want to grow our biofilm on something that's called floating bodies. So like bodies that float in the water. And we think about putting them in a separate stage in the final application, so that there's a specific stage where these pharmaceutical residues are transformed.
Yeah, a stage in wastewater treatment plants.
Right.
I don't know if you said that. Yeah, exactly.
Yeah, and then we also have an extra, like you already heard about our kill switch, our extra safety measure, so to say, where we try to, by hijacking a chrome sensing system, to keep our GMOs in place and killing them as soon as they leave the desired area or out the biofilm, which is our biofilm.
Okay. So how are you currently carrying out your experimental design right now? Are you creating models in the lab or using other modeling systems?
Basically, oh yeah, go ahead.
Go ahead, Jan.
Okay, so basically we weren't allowed in the lab this year because so far because of the pandemic, obviously. So we focused all our energy on the in silico design of our experiments and of our project, and also on the modeling part as well and human practices. So there's mostly stuff you can do from home in an iGEM project. But that's what we focused on. And I don't know if Marvin wants to elaborate on our modeling.
Yes, so I'm part of the modeling teams. First, we try to improve the enzyme design in Rosetta. For that, we do some protein calculations on our supercomputer at the Technical University. A small group is designing a Python script to model a biofilm and how the biofilm is growing, and if there are different factors, how it will flow away, and some other parameters. And a small part is going to model the kill switch with MATLAB.
Good. Okay, and you mentioned that your team has had a heavy focus on human practices. So, what are some of your initiatives that you have incorporated into your human practices portion of your project?
Go ahead, Philip. tell them about the podcast.
So yeah, as Philip mentioned, right now, our special baby for this project is our podcast that we started. So the idea behind it was to target specifically the German population. So our podcast is in German. It's not in English, so not everyone around the world can maybe hear it or understand it. But the idea was to tackle an issue that we recognized, that is that the German population is extra critical about genetically modified organisms, especially like for food and stuff. And so yeah, our idea was to reach this audience by creating a podcast that is especially in German. And we try to keep things simple. So we have like, for now, around 6 to 8 episodes planned. And in these, we discuss the basic things. So the first episode is about the general words that you need to understand the other episodes. So for example, enzyme, genome, or gene. And we also talk about like the colors of biotechnology and stuff. And yeah, just to give an insight for the other episodes, we also talk about ethics, or like the rules that you have to look at when working with GMOs, or yeah.
Yeah.
Excellent. That's really great that you're trying to reach the community and educate them on the potential benefits of using GMOs, especially when it comes to remediating pollution in water, which is, definitely a global issue.
For sure.
And I think this is the big reason we think of why people are kind of concerned about if they hear like genetic engineering or biotechnology. I think a major problem is lack of knowledge. So a lot of people just don't know anything with these terms, and so yeah, and I don't know, the situation in Germany I think is especially special. Is special because, for example, when you go here shopping in a grocery market, there's on every milk product, for example, there's a sign which says without genetic engineering. And so I see that every time, and I think all the time, no, why? And so this is also a goal of our podcast, to just give some knowledge to really the public. So that's why we also just explain what the enzyme is, what a protein is, what a DNA is, what a genome is, and stuff like that. Yeah. And so with that, we try to reach like, I don't know, adults who are like too interested in that field. But we also have another project. We designed a mini game. So it's the adventures of Dr. W. And so this reaches out to especially, I think, pupil, yeah, like kids in school. And it's just like a jump and run game where you can collect things for the lab and do some, you don't do the experiments, but you collect the stuff for the experiments, and there are like info texts and yeah, a lot of things like that. So
That's really cool and engaging. It's awesome that you want to engage a younger, both sides of the age groups in the population. I think that's really great, and a game is a really fun way to do it.
yeah,
For
I'm also
sure.
excited to play it.
That's really great. How does your team see this project being adapted for mass production? As I said earlier, water pollution is definitely a global issue, and anything that can help remediation, especially using a biofilm that's a lot more accessible, would be very beneficial to the planet and climate change, and a lot of socio-economical benefits. So what are some ideas for what the mass production of your project will look like?
So basically, what we thought about was that you could maybe send out like cryostocks with the ready organism, and then maybe people who want to implement it in their waste, for example, in the wastewater treatment plant or anywhere else where you clean water, you can look at your most common pollutants, and then we can maybe try to find an enzyme that is especially targeting these compounds, and then we would basically just one cloning step, like one enzyme that we would have to integrate, and then we would send that out to everybody, so making it quite modular. So there's might be something for everybody. There might also be other applications, but we mainly focus on wastewater treatment.
Maybe I can elaborate. I think what's great about this project is that we have like different stages of modularity. So we have the stage where we just want to put it in the wastewater treatment plant, but you can put it anywhere else where a pollution is occurring. And then you have the stage of switchable enzymes, for example. This is just like a platform where you can put different enzymes, as Jan said, onto it. And what's also great is that the cases that we actually use have a broad spectrum of substrates. And so only with these enzymes, you can degrade or transform a lot of different things. Also, for example, paint. So we read a lot about paint accidents in rivers where paint was flowing out of like an industrial building or something. And this is also doable with our lag cases.
Yeah, I think that's a very good application of what it would look like, and I definitely think that sending out a sample of the organism would definitely be functional across all waters in getting the culture started. Is there anything else your team would like the audience to know about your project or some other initiatives that your team is taking?
Maybe that you can find our podcast if you're German, like anybody else could try to hear it as well, try to understand it, but you can find it on Spotify. It's called Genominal, and yeah, would be great if as many people if we could reach as many people as possible, and if everybody who knows this or knows, if you're not from Germany, knows a German person, just share this link to everybody. Share this. Yeah, that would be great.
Okay.
To clarify, I want to tell the title in English. It's called Genominal. A bunch of styles are talking about biotechnology, and so that's the title.
Okay, great. Well, thank you so much for meeting with me today. We really enjoyed talking with you guys, and we just want to remind the audience that iGEM Darmstadt is still in the running for the Molecular Cloud and GenScript sponsorship, so go out to their page and vote for them for a chance to win our sponsorship. Thank you so much for meeting with me today.
Thank you for meeting with us.
Well. And everyone be excited for our mini game as well.
Yes.
Yes.
All right.
Take care. Bye-bye.
Bye.
Bye.